Hello everyone, welcome to this video. In this video, we shall be looking at question 18 from exercise 9.3, 18 and 19. So let's first of all have a look at question number 18. In this question, we are required to calculate the sum up to first n terms of this sequence 888, 888, 8888 and so on. Now you see this is not a GP. This is not a AP because here the difference of any two terms that is not constant. Here the difference is 80, here the difference is 800, here the difference is 8000 and so on. So therefore it is not an AP. What about the ratio? We have 88 upon 8 not equal to 888 upon 88, and similarly 8888 divided by 888 not equal to 888 divided by 88. So therefore it is also not a GP, right? So if that is the case, we have to manipulate the things as we have done in some previous video, if you remember. Okay, so we need to calculate this sum 8 plus 88 plus 888 plus 8888 and so on. So what we can do, we can take 8 common from each of the terms so that we are left with 1 plus 11 plus 111 plus 1111 and so on, right? Now what we can do, we can multiply and divide by 9. So we can do like this, we can shift this 9 inside, so it will be multiplying with all of these terms, so that we would have 999, 999, 9999 and so on. Now we can write each of them. 9 could be written as 10 minus 1, 99 could be written as 100 minus 1, 999 could be written as 1000 minus 1, 9999 could be written as 10,000 minus 1 and so on. Now what we can do, we can combine all the 10 terms. So 10 plus 100 plus 1000 plus 10,000 into one bracket, and we are left with minus 1 minus 1 minus 1 minus 1. How many times? Up to n times. So we are having this term. Now in order to calculate these two sum, first of all consider this GP. Let's call this as first GP. Here the first term, this is a GP because the common ratio is 10. And you divide each term with its preceding term, you will have 10 as the answer. So common ratio is 10, the first term is 10, so the sum would be calculated because the common ratio is 10 greater than 1. The sum would be obtained by using this formula, Sn is equal to a r raised to power n minus 1 divided by r minus 1, correct? And in the second case, in this case, we have our GP as a as the first term, r is equal to 1. So if r is equal to 1, the sum is calculated up to n terms. It is given by the number of terms n into the first term. So the number of terms in this case is n multiplied with a, that is the sum. So the sum here is obtained like this, n into the first term, which is 1, correct? So we have in place of this the number n, in place of this formula a r raised to power n minus 1 divided by r minus 1. So we can simplify the terms, 8 upon 9 as such, 10 upon 9, right? 10 raised to power n minus 1 minus n, and we can simplify the bracket over here, so it would become 80 by 81 into 10 raised to power n minus 1, this is first term, and 8 by 9 minus 8 by 9 times n, this is the second term, and this is your answer. This is the sum of this series up to n terms, correct? So I hope you understood this question well. Let's move on to the next question, 19th. Here this is a very interesting question. Let's have a look at it very quickly. So here you are given two GP sequences. One contains the numbers 2, 4, 8, 16, 32. That means here the first term is 2, and the common ratio for this GP is 2. For the second GP, we are given the numbers 128, 32, 8, 2 and 1 by 2. So here the first term is given to be 128. The common ratio is given to be 1 by 4. Now what they are saying, they are saying we need to find the sum of what GP? The GP which is produced by obtaining the product of the corresponding terms of these two GPs. So that means we will multiply this 2 with 128, this 4 with 32, this 8 with this 8, this 6 with 16 with 2, 32 with 1 by 2. So that we have the third GP, it would be 2 into 128, 4 into 32, 8 into 8, 16 into 2, 32 into 1 by 2, as I have told you, right? So solving them, we obtain 256, 128, 64, 32 and 16. So this is our GP, and we need to find the sum of these 5 terms. So here you can clearly see the first term is 256, and the common ratio when you divide each successive term you would have as 1 by 2. So now we can very easily calculate the sum here. We know because the common ratio is less than 1, we will use this particular formula to solve the sum. The value of n is 5. In total we have 5 terms. So therefore S5 would be a into 1 minus r raised to power 5 divided by 1 minus r. So simplifying this, we have 496 as the answer. Here, in order to solve this question, we have one more way. What is that way? What we can do, because we are given the first GP as this one, second GP as this one, with the first terms and common ratio as 2 for the first GP, first term and common ratio as 128 and 1 by 4 for the second GP. In this case, for the third GP, in order without writing all the entries of the third GP, what we can do, the first term is obtained by multiplying the first terms of the first GP with the first term of the second GP, which is 2 with 128, which is 256. Right, so this would be the first term of the resulting GP obtained by multiplying the corresponding terms. Here we are not actually calculating the GP, and the common ratio of the first one is 2, for the second one is 1 by 2. So the common ratio for this third GP would be obtained by multiplying the common ratio of these individual GPs, which is 2 into 1 by 4, which comes out to be 1 by 2. Now notice that this and this, they are just same as the one with the previous case, correct? So therefore, now we can directly apply the formula of sum of the GP, which is obtained by multiplying the corresponding terms of first and second GP. So the formula would be the first term of the third GP, 1 minus the common ratio raised to power 5 divided by 1 minus the common ratio. Substituting all the values and evaluating, we have 496 as the sum of the first 5 terms of the third GP. So I hope you understood these two questions well. Well, that is it for this video. Thank you for watching.